Oh, no. Okay, so just to recap some of the stuff we kind of rushed through at the end of yesterday's lecture. That was what we were doing. So when you've got fractions of stuff, if you times them together, you can just times through the top and the bottom. Okay, and then when you're doing dividing, you do exactly the same, except you flip the thing that you're dividing it by upside down, and then you can times through the top and the bottom. Okay, to simplify these kind of when you're dealing with multiple fractions divided by or multiplied. Okay, so the next bit, which is new for today, is what we do is when we have these situations where we have brackets surrounding parts of an equation that are not just one thing times another thing times another thing times another thing. Okay, so you recall from yesterday, if this was just A times bracket B C close bracket, that's just the same as timesing A by B times C. Okay, you can just multiply through the whole bracket. But in this case, we can't do that because we've got this plus in the middle. It works the same if you've got a minus. Okay, so what the rule is, okay, when you're timesing something in a bracket, okay, by something, in this case A, okay, you times everything, every bit that's kind of separated by a plus or a minus. Separately, you multiply it out by the thing at the front. Okay, so you times A times B and also A times plus C. Okay, and in the same case, the bottom here you times A times B, which is AB, and then A times minus C, which is minus AC. Okay, so you times, if you've got a plus or a minus inside your bracket, that means you have to multiply out each term separately. And there are some kind of like fancy graphics on here. Okay, and this will become more important as we move on to some more complex equations later on. Okay, so I think this is just some examples. Well, these are some examples. This is never mind. But if we just think about how this kind of works at a really, really fundamental basic level. So in this case, we've not got any algebra in this at all. It's just numbers. If we think about what this actually means. So if we have 3 plus 2, okay, that's 5. God's sake, that's 5. So if we times 3 plus 2 times 2, that's 10. Okay. So, but if we do it the way that we did the multiplying out everything individually, okay, we'd go 2 times 3, which is 6. Okay, good, excellent. And then 2 times 2, which is 4. So 6 plus 4 is 10. Okay, so you can see how working the thing in the bracket out first and then times it by the front, you get the same result as you would if it's fine. Then if you times everything out individually. Yeah? Pretty happy campers? These are more complex examples. Okay? But should we do these ones? Yeah, so let's... No, we won't do those ones. We'll do... moving on from that kind of simple example where you just have one thing outside the bracket times everything else, okay? Where we've got 2 brackets times everything else, okay? So this is the same as basically all of this times all of this. So once again, if this was just AB in a bracket and then CD in a bracket, that would just be AB, CD times each other, okay? But because we've got these pluses in here, okay, what we could do is we could basically separate out this bracket into the C part, and then basically C times AB, and then plus D times AB. Okay? So when we do that, we do the first bit C times AB, so that would be AC plus BC, and then we do the same multiplying it out this side. Okay? Just like that. Now we can look at that and think, yeah, so that, I mean, that would be our kind of answer for that. Okay, we've multiplied out all of the terms each by each other when we've got these 2 brackets with a plus in each one of them. Okay, similarly, if we've got a minus, it's a little bit more complicated. But once again, so if we just look at the first part, C times this bit here is C times AB. Okay, we can multiply that. That would be AC plus BC. and then we've basically got minus d, okay, times everything in this bracket, and that's what we've got here, okay, which is the same as saying minus 1 times d times what's in the bracket. So we can basically move that, imagine we've got minus 1 in there, times, so minus something, minus a, or minus x, or minus 13, okay, is the same as saying minus 1 times 13. Minus 1 times x. Think of it as if you've got a minus in front of it, you can basically just put a minus 1 times something. Sometimes helps thinking about how you should be multiplying things out. Okay, so that basically multiplies that to that. Okay, so you end up with the minuses in there. Okay, so this is where I wanted to get you to do some examples. Okay, so I'm just going to. Okay, so this is what we've done here is kind of multiplying out brackets. Okay, so we've got brackets with like something plus something and something plus something, and we've multiplied them out. Now, factorization is essentially doing the opposite of that process. Okay, and the reason we do this is because this actually helps it a lot easier for us to rearrange equations and find the thing that we're actually looking for. Okay. So it's commonly called grouping common factors. Okay, so it's basically like finding a common multiplier. Okay, and let's go through some simple examples. So in this case, 3x plus 12. Okay, so that's got two parts to it. Okay, so that's got two parts, and I'm going to actually get the board rubber now because I know where it is. So 3x plus 12. Okay, so 3x can be divided by 3, right? If you divide 3x, you get, yeah. And also 12 can also be divided by 3. Okay, so 3 is a common factor of both of these parts of this equation. So I can basically take that out, okay, that 3 out, and then I can make a bracket, okay, that is what this is divided by our common factor. Okay, so in this case, 3x divided by 3 is just x plus 4. Okay? So in this case, I've grouped a common term, which is 3, and factorised that kind of equation. Do that one, or... Yeah, let's go full retard. Let's do the bottom one. Have you guys seen Tropic Thunder? Yeah, awesome. Anyway, so if we look at this bottom thing down here, okay, so this is a pretty nasty looking equation. If we were asked to manipulate this around, so see if you can find the common factors on this. Okay, so we want to find something that's in that, that's in that, and that's in that. Okay? And let's not bother with the top hat unless I think for this one. So, so the numbers, we've got 16, 8, and 24. Okay, all of those can be divided by 8. Yeah? Pretty happy with those being divided by 8? That's really badly drawn 8. All of these terms, okay, these separate things that are all multiplied by each other, they all have at least one b in there. So I'm just going to take 8b out. Okay? So if I was to divide this by this, it would give me 2ac. Okay? If I was to divide, now in this case we've got a minus here, so think of this term as all of that. Okay? And this term is all of that. And I guess we could put a plus on the front of that, and that term was all of that. Okay? So in this case, minus 8ab squared divided by 8b. Okay? So we're dividing a negative thing by a positive thing. So we're going to have a negative. Okay? And it's going to be 8 divided by 8 is 1. Okay? ab squared divided by b is going to be ab. Okay? And then we can do the same thing for this bit over here. 24 divided by 8 is 3. In this case it's going to be plus 3c. Okay? And minus 1 something is just the same as minus something. Okay, so that would be, we've now grouped out this common factor here. Okay. So the reason why we're doing this is because if you can find a common factor, so for instance in this equation here, okay, if we wanted to find out what x was, okay, if we knew all of the other variables, okay, if we were to do this whole process, okay, we could use the common factor and try and isolate x to one side of the equation. Okay, so if this was an equation that maybe equals 0, okay, we could go around trying to kind of like rearrange that if we like if we thought we kind of like could move things around enough, but we could just look at that and go, actually x is a part of each of those things. So I'm going to say that x open bracket and then x goes into itself once, okay, plus 2y plus 3yz equals 0. Okay, and then you've isolated x into one part of the equation, and then you can kind of rearrange the whole thing. Okay, so in this case x would be 0, but that was a badly thought out example. But the point I'm trying to make is that you can use this process to isolate terms that are in quite a complicated equation that have got the variable you want in it multiple times, okay, which are actually quite hard to solve. But it's really powerful for that. Anyway, so moving on now. So once we've got to use these techniques of factorization, so making things into a bracket and kind of like multiplying out brackets to investigate these things called quadratic equations. Okay, so a linear equation is something that if you were to, for instance, draw, they're called linear equations because if you were to draw a graph of maybe y equals ax plus b on something that looked like y and x, okay, that graph would be a straight line, okay? Depending on what these variables are here, I mean, it could be a line like that, line like that, line like that, but it will always be a straight line, okay? Quadratic equations, okay, are basically just very similar to linear equations, except they have this additional term where one of the variables is raised to the power 2. Okay, so quadratic equations are specifically where one of the equations is raised to the power 2, and those equations have forms that look like this, okay, or like that, okay, sometimes even like that, but we're not going to go into this, okay, sometimes they're like that, okay, they're bending. Okay, and it turns out that those kind of equations are actually really useful for a whole bunch of areas in science, particularly geosciences. So this is generally the type of equation is named after the highest exponent. So a linear is if this is to 1, quadratic if this is to the power of 2, and we'll see why it's quadratic, why quad when it's a number 2. Cubic equations, kind of just, I mean, they look crazy shit like that, right? And higher power ones, quintatic equations and stuff like that. Don't need to, yeah, I wouldn't bother with those either. But you'll come on to those in EMP2. Yay, fun times. But we're going to stick with these guys at the moment. Okay, so there was this, yeah. So some member of parliament was debating kind of science education, was like, why do we need to teach children about, quadratic equations? What's the point? They're hardly used in anything. And of course, because he was a political douche. But these are really important types of equations. So this is a quadratic equation. You can see the values x and y are raised to the power of 2. So this is kind of a special case where more than one of the variables is raised to the power of 2. Okay, but nonetheless, it's really important for earth sciences because it use these kind of things to describe the orbits of planets. Okay, this has got really important climatic implications of having an elliptical orbit, and that we can describe those in terms of quadratic equations. You come on to that into my part of ELE. This is not an earth sciences example, but quite often things in the earth are accelerated. Okay, so the description of basically speed equals distance divided by time, we can go take that one a little bit further and take a term. So this is basically speed, distance. This is distance. Annoyingly, so the terminology, basically what these mean, changes depending on who wrote down the equation. So in this case, this is S is displacement, how far something has moved. U is the velocity of that thing. Why we don't use V, I've got no idea. Times time. Okay, so that's basically the first lecture there. Okay, but a little bit more complicated model. What if we're carrying on accelerating that? Okay, and in this case, it's not some guy. Let's assume it's a guy, or woman, whatever, driving a car, constantly accelerating. Okay, so if we wanted to describe where that car was in terms of displacement, we need to know how fast it was starting initially and how much it's been accelerating. Okay, and this kind of is the same as things accelerating down due to gravity. So this kind of equation is really important in things like volcanology. If you're looking at where volcanic bombs might be landing, how far volcanic ash gets distributed, so how things are being accelerated through the atmosphere, but also in the ocean. So this is one of the fundamental equations of almost all climate models. Okay. Got a packet of air, how fast is it moving, what forces are acting on it, how fast it's being accelerated, okay, over time. And this, basically, in this case, t is our variable that's raised to the power of 2. That's another thing that moves. Just some more examples of where these kind of equations kind of pop up in nature. So if we wanted to describe, basically, this is the set of equations that describes A4 paper, or the A series of paper. Okay, so if we basically take a square, okay, and if we want to basically make it the aspect ratio length to height of A4 paper, we basically make the length or the width equal to the length plus or minus 1 minus the height, like that. Okay, details of this don't matter, but this is basically allows like your so this equation here can be rearranged into a quadratic equation, and it ends up with this kind of like having this ratio of length to width of objects that has this thing called golden ratio, and it's kind of basically it's a particularly a very aesthetically pleasing kind of ratio, okay, to have people like things that are that shape. But it also means that if you were to put another one of these down here, okay, it would then have the same aspect ratio, the same ratio to length to height as the original one did. Okay, no other rectangle will do that. Okay, and you see it in all kinds of things. So that's some Italian woman. But you see it also in things in spirals in nature. You see it in kind of spirals in nature in kind of like multiple scales. So this is a foraminifera. This is kind of a galaxy. So you see this kind of equation, this quadratic equation that explains the shape of these things appear up all over the place. Okay. So how do we go about manipulating these equations to basically just try and solve them? Okay, so to start off with, what we're going to do is we're going to take this general form. Okay, so this general form is basically describes any quadratic equation. Okay, okay, and quite often you'd make these to equal 0. Okay, if they don't equal 0, if they equal some number, we just minus that number from both sides of the equation to make it equal 0. So, for instance, if we had ax squared plus bx equals 7, okay? So if we come up with some equation that's like a equation, if we just minus 7 from both sides, ax squared plus bx minus 7 equals 0, okay? So sometimes you'll have to do that very simple manipulation to get something of the form, something times your secret algebraic variable, x, t, smiley Batman symbol, squared plus b times that same thing, plus just a number, okay? That's the general form. Okay, so if you see something that looks like that, probably you're wanting to do something with this quadratic equation, okay? So what we're going to do is we're going to basically try and go from something that looks like that at the top, okay, into something that looks like this, okay? And the reason we do that is because if we make our equation, if we say that a x squared plus b x plus c equals 0, okay? If we can somehow turn that into 2 brackets equals 0, doesn't matter what's in these, okay? If this is 0, okay, at least one of these must also equal 0. Yeah? So, I mean, if we had something in here, so like x plus 7 or something, right, in this one, and maybe x squared plus, wouldn't be an x squared plus 5. One of those would have to equal 0, okay? Then we could say, basically, x plus 7 equals 0, or x plus 5 equals 0, okay? And then we could quite easily rearrange both of those to say x is minus 7 or x is equal to minus 5, okay? So then we can use this approach of turning this into 2 brackets, and that will give us 2 answers, okay? And it's okay to have 2 answers for a quadratic equation. And the reason for that is if we look at graphs of quadratic equations, okay? So, if this is y, and this is x, okay? So if I had an equation y equals x squared plus 2x plus 1, something like that, right? That is going to look something like, minus 1. That's going to look something like that, okay? Yeah? And if I was asked to solve that for a value of y, yeah? So when y equals 0, so when y equals 0, what does x equal? Okay, or we could do what's y equals, when y equals 5, what does x equal? Okay, when y equals 0, there are 2 values of x, yeah? And when y is 5, there are 2 values of x here as well, yeah? Read off there, okay? So bear in mind that with these kind of equations, if I'd asked you what is the value of this when y is equal to minus 5, okay, that's kind of down here somewhere, there is no value of that equation, okay, that will satisfy this situation. So sometimes, okay, these equations cannot be solved, okay, which means that those equations are wrong, okay, and that finding an equation where you can't solve it sometimes is useful, okay. So that can sometimes tell us something about the system. So just bear that in mind. So what we're going to do is we're going to look at ways of turning something like that at the top into these guys. Okay, and the way we're going to use that is by basically knowing that the answer is going to be something like x, okay, plus, is going to be something like that. So it's going to be x plus some number, and then x plus some other number. Okay? And the reason we know that is that if we just take this generic equation here and multiply out these brackets. Okay? So if we multiply out, first of all, the first thing, so x times x is x squared. Okay? And then we're going to times up the other thing, so plus x n. Okay, then we take the other thing this term, we look at x m plus yeah, n. Okay? So in this case now we could look at this part here, okay? And we can see that that has a common term, okay? xn plus xm are both divisible by x. Yeah, I did know. I'm not just. So we could simplify that to x open brackets n plus m. Yeah, and if n and m they're just numbers, we could just add those together, right? So that gives us an equation that's x squared plus x times something plus m times n, which is just going to be a number. Okay? So that is essentially what we've got up there. Okay? Yeah? So what we need to do is think about how we go from that thing at the top, okay, to figuring out what these numbers here are. Okay? So that's, I guess this is kind of just what I've been through. Okay, so just multiplying all that stuff out. Okay, you end up with something that looks like, okay, this. Can you guys see that? Is it hidden by the things? Okay, this has the same form as the red thing at the top. Okay, so if we can figure out what m and n are, yeah, then we can basically start to solve these quadratic equations. Okay, yeah, so that's where we were. So basically, how do we go about figuring what m and n are? Okay, so let's just go through this example in the last kind of like time here. So we know that we've got to have we've got this relationship at the top here where our x plus m times x minus n is going to equal our thing that looks like the quadratic equation. Yeah? So we want to do this thing backwards now. So we know that this term here, this 5, this plus 5, that's got to be one number times another number. Okay? M times n. So we could write down that m n equals 5. Okay? We also know that m plus n, okay, m plus n, that is going to equal 6. Okay? Yeah? Okay, so what we need to do now is try and guess what those numbers are. And that's all we're going to do. We're just going to try and think about, can we think of a number, two numbers that you times them together and you get 5, and you add them together and you get 6.
5 and 1.
Yeah, 5 and 1. It's not. So we could then figure out that that's 5 and 1, and then that would mean that one of the numbers is x plus 5, and the other one is x plus 6. Yep. Okay, and that means that x is equal to minus 5 or minus 6. Okay, so we've solved that equation. Yep. Pretty straightforward stuff, huh? Yeah. So we could do the same thing for this one here. So very similar equation, but in this case we're looking for two numbers that you times together to get 6, but when you add them together you get 5. Anybody? It's not 5 and 1. 3 and 2. Yeah? So in this case, x will be minus 3 and minus 2. Okay, it gets a little bit more complicated when you have kind of like nasty things like that, and when you start to have negative numbers. Okay, so we'll just go through this example here. Got something, two numbers that times together to give you times them together, you get plus 6. Okay, when you add them together, you get minus 5.
The 2 and 3 again, but in the brackets it would be minus.
Yeah. So so because when you're timesing minus 3 by minus 2, okay, you get plus 6. Okay, and when you're adding minus 3 to minus 2, that's the same as minusing 2 from minus 3, takes you to minus 5. Okay. And I guess there are also, I guess we'll just end on these last two examples here, where we've basically got these cases of what we would call a perfect square. Okay, where basically, if we think about what that means, if we try and just work out what the two things in brackets are for this guy here. So we want two numbers that you add them together, sorry, you times them together, you get 25, but you add them together, you get minus 10. Okay?
Minus 5 and minus 5.
Yeah, so in this case, okay, both of the numbers are exactly the same. So we'd have just, so this would become x minus 5 and x minus 5. Okay? So it's called a perfect square because it's one thing times the exact other thing. Okay? So that's why they're called quadratic equations. And then the other kind of like special case is where you have basically a quadratic equation that doesn't have this second kind of variable in it. Okay? And the reason it doesn't have that variable is we're using exactly the same kind of like formula manipulation up here. We want one number that when you times, two numbers that you times together to get 81. Okay? First we get minus 81, sorry. But when you add them together, you get 0. Because 0x is just x. Okay? So in this case, the number is the same, so you basically, so you have, it's not the same, so if you times 9 and minus 9 together, so you get minus 81, but if you add minus 9 to 9, you get 0. Okay, so in this case, this term is basically the difference of two squares because you're basically cancelling out those two terms. Okay, so we'll leave it there today. We'll go on to more quadratic equation fun and other things like that next week. So you've got, have you got your tutorials sheets available for this week? Okay, so you've got those available, and you've got your first tutorial this week, and then the next hand-in thing there. Is it Carrie? Who's that? Callie, as in Caledonian. Okay, sweet. So if you could come over up and give me your student number, and then I'll be able to email stuff, and we'll do things. It'll be fun.